Okay, in part B of the motion of charged particles and motion of charged particles in magnetic fields, we're just going to look at an example problem that uses the concepts that we just explored in the previous video. Just be a short one. Okay, so let's look at an example problem. We've got a magnetic field here directed into the page. It's the tail of the arrow we're looking at. The magnitude of the magnetic field is 2.5 times 10 to the minus 2 Tesla. An electron. As soon as we see electron, hopefully we're thinking negative charge. Travelling with a speed of 1.45 times 10 to the 6 meters per second in the plane of the page enters the magnetic field, as shown by that arrow there. On the diagram, sketch the path taken in the magnetic field. So, fingers in the direction, thumb in the direction, but this is a negative charge, so if you like, it won't be out of the palm, it'll be out of the back of the hand. So basically it will curl around in circular motion like such. It's not the greatest circle, but I think that'll do. Now, once it leaves that magnetic field, it's not going to continue in a circular motion, but it doesn't ask me to sketch it when it leaves the field, and I'm not going to risk getting something wrong by sketching it outside the field. So I just want to show that we've got a circular path inside the field. If you think your diagram might be so bad that it might be misinterpreted by someone marking, write circular path there. Just that confirms in the marker that you do know it follows a circular path. Because to be honest, my diagram's not great there. Then calculate the magnetic force acting on the electron. So we use the formula F equals Q V B. Obviously sine theta, but it says that we can see from the information that it's at right angles. So we might either drop that, or we might just go sine theta and then just go, well, that's all equal to, that's all equal to 1. So we can just forget that term for now. Sometimes I'd say write down the info in the question, but I think at this point, given this formula is on the formula sheet, this is what you're trying to calculate. You can, there's probably nothing wrong. Hang on a sec. Sorry, just a little technical issue. There's nothing wrong with substitute it straight into the formula. Force equals Q. Charge on an electron, 1.6 times 10 to the minus 19. Hopefully by this point in this topic that's been well and truly smashed into your brains. 1.45 times 10 to the 6th is the velocity, times by 2.5 times 10 to the minus 2 is the magnetic field strength. And I will pause and calculate that. Okay, so we've calculated that, 5.8 times 10 to the minus 15 newtons. It seems a bit small, but we're dealing only with an electron here, which is a very small charge, so you wouldn't experience a huge force on such a small object. So I think that's a reasonable answer. If you're struggling with still these sort of calculations, it's a good one. Plug into your calculator and make sure you get that right answer. And if you don't get that answer, double check. And if you still don't get that right answer, maybe come and tell me to double check that I got the right answer. That ability to pump numbers correctly into your calculator is sometimes an underestimated skill. Not only do you need to be able to do it accurately, but you also need to really be able to do it as quickly as possible. So you're not wasting time in a test or an exam on that, which could be better spent on other things. That's it for example problem. We'll go on and look at the application next.